Welcome. So this question says a 2 coulomb positive charge sits at the center of a spherical surface of radius 8 meters. And then it says, what is the electric flux through the surface? So here's my positive charge, 2 coulombs positive. And then I'm going to draw a spherically symmetrical Gaussian surface. So this is a sphere that has its center exactly where the 2 coulomb charge is, and it's 8 meters away, so let's just draw that as 8 meters. And it's asking for the electric flux, which is, if you like, a measure of the number of electric field arrows puncturing the surface. So I'm visualizing it looking like this, a whole bunch, like a porcupine or a hedgehog kind of coming through. These are electric field lines. So each one is an electric field line, and the flux of electric field lines, if you like, well, the flux of electric field lines is equal to, it's going to be the integral of E dotted with dA, because we have this little window and each one has a little area dA. The electric flux goes through it and we add it up for all over this surface, and this equals Q in over epsilon naught. That's permittivity of free space. This is the charge inside the Gaussian surface. This is our old friend Gauss's law. And I'm actually not going to worry about the in-between bit, actually. I'm just going to, this simplifies. It's just basically the flux is equal to Q in, and Q in is going to be plus 2, because it's plus 2 coulombs, over epsilon naught. And if I wished, I could say, well, okay, that's going to be my flux, and looking up here, I would see that it is in newtons per coulomb multiplied by meters squared, same as usual. And there's my answer, which is A. But let's say I want to go a little bit further than that. I could say, well, it's plus 2 over, and then my permittivity of free space, what they call epsilon, that's the Greek letter epsilon naught, meaning, 0. And that would be 8.8 times 10 to the minus 12, and its units are farad per meter. Doesn't matter about that. So then we work this out and we get, well, let's look to, that's going to be 2.27 times 10 to the 11 newtons per coulomb meter squared. And if you take this flux measure as being a kind of indicator of the number of arrows I'd like to draw through this surface, that's a lot of arrows. So there we have it. It's don't get fooled into thinking we're always going to do this integration. Sometimes all you need to do is know the charge inside and divide it by a constant, and you'll get your flux. There we have it.